Thank you. Brilliant talk so far. So imagine you get a brand new phone, and just a week later, oops, you accidentally drop it. All of us have dropped our phones at some time. But instead of shattering, the phone magically rearranges its circuits, adapting to work perfectly without needing any repairs. Sounds like science fiction, right? Well, that's exactly what our brains can do. After an injury, the brain has this incredible ability to rewire itself. This process is called neuroplasticity. It is how our brain learns, adapts, and repairs itself after a stroke or injury. And this is what we study at the Brain Plasticity Laboratory. With the help of cutting-edge science, we are working to make recovery more effective and help people with neurological disorders rebuild their lives. So we use advanced tools to study how the brain rewires during recovery. These include TMS, or transcranial magnetic stimulation, which uses magnetic pulses to map brain circuits. We use transcranial Doppler imaging, which uses ultrasound to measure brain blood flow. We also use functional magnetic resonance imaging to show which parts of the brain are active during movements. And we use diffusion tensor imaging to visualize connections between different brain regions. Our research has shown something really exciting. Recovery isn't just about pathways on the opposite side of brain injury, as we typically thought. We recently published some important science on the role of ipsilateral pathways, those on the same side of the brain as injury. What does this mean? It means that this gives us new ways to improve therapies by targeting these novel pathways, potentially speeding up recovery and enhancing outcomes. After brain injury, the brain sometimes needs a little extra push to unlock its potential. This is where cortical priming steps in. So think of cortical priming as preheating an oven before baking. Just as cookies will not rise in a cold oven, the brain responds better to therapy when it is primed. We use tools such as non-invasive brain stimulation, such as transcranial direct current stimulation. We brain scientists love our acronyms, TDCS, to prepare the brain to relearn motor skills like walking. We're also studying other new priming modalities like digitized movement priming with gamification and remote ischemic conditioning to help prime the brain. But I strongly believe that recovery should not stop at the clinic door. With telehealth, we are taking brain priming beyond the hospital, making it accessible from the comfort of one's own home. Picture wearing a TDCS cap, like a beanie, while engaging in therapy sessions remotely without long commutes or waiting rooms. Rehabilitation from your couch, in your pajamas, that is the future of healthcare.